Great. Thank you so much. It's such a pleasure to be here. Good morning and good afternoon. I'm really thrilled to be here to be able to talk a little bit about large language models and social science research. As Eric mentioned, I'm going to be talking about this sort of through the lens of some of my own research, but also sort of some bigger picture questions. So a little bit of an overview of what we're going to do today, which is a lot. So I apologize in advance for how much information is about to be in here. I'm going to start with a brief overview of large language models, just to make sure that we're all on the same page. I imagine this will be a review for many of you, but it's sort of relevant to some of the points that I want to make later. And so hopefully it's sort of helpful ground to cover so that we're all on the same page in thinking about what large language models are and what they can do. Then I'm going to cover a couple of potential uses, and this is going to be a very brief overview of two of our published research projects. I say we, all of this is co-authored work, so I'm sort of taking credit on behalf of a big team that does this work with me. And I'm hoping that sort of like through a brief introduction to those projects, we can get a big picture view of some of like the opportunities, some of the excitement that we feel in this area. But I'm going to lead that into some cautions and caveats, some things that have changed, some things that we should be thinking about, some of the challenges that I see facing large language model research at the moment. And then take that into some considerations for the future. And so there, I'll make some propositions about what, as a field, we should be doing and talking about in terms of creating good scientific standards for the use of large language models. So that's the big picture plan that we're going to cover. And starting with a brief overview of a large language model. So generative language models are sort of conceptually very simple, although they are very large and very complex underneath the hood. And so really a large language model is a very complex conditional probability distribution over words. And so it might look something like this, where we have some predicted word or token that is the probability of which is based on a set of other words or tokens, which we can call the history, the context. You're probably most familiar with thinking about it as a prompt. So if I were, for example, to say, can you please come, you might think of some words that are likely to follow that sentence, right? There are a set of things that seem like natural ways to complete the sentence. There are a set of words that wouldn't make a whole lot of sense and wouldn't get a lot of meaning to the sentence. And so if I say, can you please come here, that might make sense. That's a highly probable way of completing the sentence. There are other words you could say, can I please come home? Can you please come home? And that would also sort of make sense. Those are pretty probable ways of completing the sentence. Can you please come bananas? Not as probable. And so we sort of have some expectation that like there are ways to fill in the sentence that make sense. And generative language models are trained in this way, in predicting the next word and being rewarded if it gets the next word right and penalized if it gets the next word wrong. And so through that process over huge swaths of data, it learns what sort of the probability distributions are about different tokens that could possibly complete a sentence. So for example, if we take the students opened there, we can put it into the large language model. And then what it's going to do is give a probability of every token, as sort of symbolized here from A to Zoo. It's going to give a probability of all of these different tokens occurring as the next word in the sentence. So books might be a very highly likely one. Laptops might also be a very likely outcome, but like zoo is not very likely. It still sort of semantically makes sense, but is not very probable. Okay. So this is what language models are doing underneath the hood. And they do it one token at a time. So if we say, for example, feed into the language model, recite the first law of robotics, it's going to go into the language model and give us the most probable next first token, so A. And then it's going to go back to the beginning and start all over, recite the first law of robotics, A, and then it's figuring out the next most probable token. So it's doing this one token at a time as a prediction task of what the next word is likely to be. Here's another way of visualizing it. Hopefully through all of these images, we're getting a pretty good picture. If we started with I like as our prompt, there's some probability for all of the next words, sort of for example's sake. So like you might have a 38% probability of being the next most probable word. But it's doing this one token at a time. So if I like, and then it's sampling from a distribution of possible words, it sort of comes up with the probability and then samples from among that probability distribution to pick the next word. So it might say, I like being, And then there's some probability of words that come after I, like being. So we're adding in the next word in the first word generated and running it through again, adding in the next word generated and running it through again. So in a lot of ways, it's really just a very big, very powerful, like predictive text engine, just like predictive text on your phone. Okay. So what in the first couple of projects that I'm going to talk about in just a minute, we're talking about the GPT-3 language model. GPT-3 was released in the summer of 2020. So about 3.5 years ago. This is prior to ChatGPT. This is prior to, there's lots and lots of excitement about GPT-3, but it's not sort of publicly open in the way that ChatGPT is. But GPT-3 is sort of like the paradigm shifting model. It's really, really, really big. That's pretty much its big quality. It's a very big model that does this kind of predictive text work. Text generation through predicting the probability of whatever the next token is to come. Oh, one thing, I sort of used words and tokens interchangeably. There's a good example of what we mean by tokens and why we say tokens instead. So if you follow the path of I like you, the next most probable token is a period to end the sentence. So tokens can also be sort of like stop indicators, punctuation, in addition to words or parts of words. All right, so our team is a group of computer scientists and political scientists. We got together and started thinking about what GPT-3 as a tool might mean for social science research and what opportunities were in store. And we started with sort of this premise that large language models are based on text written by a lot of people. And so it's possible that in addition to understanding just probabilistic relationships of what word comes next, we're actually encoding into the language model a lot of other information about human nature, right? We can learn a lot about authors from the way they write their stories. We can learn about human psychology from the kinds of things we want to write and say. And so as political psychologists, we say, well, maybe there's some actually some information in there about humans that language models are picking up and absorbing because of the way that we are writing and because of the way that it's trained on text that is produced by human writers. So we asked this sort of big picture question and said, what if large language models are storing more information than just probabilistic word associations? What if those probabilities actually, you know, deep underneath all of that, tell us a lot of information or sort of like replicate a lot of things about human psychology, human thinking, human politics? So what we want to know, and this isn't sort of like a new idea, this is sort of the basis of algorithmic bias, is that we're training models on data that has biases because it's generated by human processes. But we wanted to know if these biases in the model could be a scientifically useful feature instead of a bug. So we often think about algorithmic bias in a paradigm of a problem, something to be mitigated, but maybe these biases actually tell us something about humans and can be useful to us. And so we wonder how could we extract that information from the model? How accurate is it? How useful is it? So this is sort of like the starting point of our initial project. So here's where we'll transition away from sort of like high level general overview of what language models are and do into a specific application. And so for this specific application, I'm going to give you sort of like a partial and quick rundown of our out of one many project. Using this, so this was published in Political Analysis last year. And what we want to do is use language models to simulate human samples and see how accurate they are, see what can happen. And our sort of big idea, the big like radical paradigm shifting thing that we wanted to toy with is maybe generative language models are accurate enough at simulating people that we could study them as if they were people. Is that possible? Would we come to the same kinds of conclusions if we were to sort of generate data with language models relative to generating data through survey research? And we start with this idea of algorithmic fidelity. So this is an intentional foil to algorithmic bias. And it's sort of trying to turn it and say how much, to what degree is the bias or the many biases. This is a big part of the title of that, is that we think there's maybe not just one unitary bias of a model, although we often talk about algorithmic bias in that way, as sort of a singular feature of a model. but maybe there's actually lots of different biases that we can uncover. And those biases aren't, they're reflective of the real world, right? So it's not that there's something sort of like aberrant or something different than what's really going on in people's heads and minds. People have a lot of social and psychological biases, and maybe the biases that we see in language model, the many biases that we see in language models, are reflective of them. So we're calling algorithmic fidelity the degree to which the complex patterns of relationships between ideas, attitudes, and sociocultural contexts within a model accurately mirror those within a human population. And then we come up with a set of standards. So what we need to know going into this project is if we think that the language model is behaving a little bit like people and is encoding this information and can sort of accurately represent sort of people's attitudes, thinking processes, has algorithmic fidelity, what does that look like? How do we know if we get there? And so we propose 4 standards. I'm not going to spend a lot of time on them here, but I think it's important mostly just to note that we have to have some kind of standards. That's a point I'll come back to a little bit later. So one of these standards is the Turing test. We think that it should look, the text that's produced by the model should look like what humans would have produced in that context. We say there should be some backward continuity. And so the things that we're feeding into the model should then be consistent with what sort of comes out of the model. Some forward continuity. So it should be sort of like the same form, the same tone, the same context as what went into the model. So thinking about that prediction, we should be sort of like predicting in a way that is sort of consistent with what we're looking for, what we're doing in that particular, generative production task. And then some pattern correspondence. So what we say is like, this shouldn't just be like a surface level sort of correlation. It should go beyond that. We should see lots of sort of complex interactions and relationships between lots of different kinds of variables and outcomes. So we come up with a process which we call silicon sampling, which is where we provide detailed demographic information in a prompt for a range of different people. And then we're having GPT-3 sort of complete the same survey questions, the same tasks as humans do. So we're using the prompt window to then sort of like tell GPT-3 change that probability distribution, tell GPT-3 the sort of like demographic space we want it to inhabit, and then see what it says as a result of the questions that come up. And so we have, we're sort of talking about a human sample and then a silicon sample. So we're using real human survey data. I'll tell you about 2 of the sources that we use in just a minute. And then we're sort of like matching, given this backstory, or what we call a backstory, given this sort of like backstory in the prompt, does the language model then produce the same thing that we would expect a human to say or do in that situation? One of the important things here is like, even if the one-to-one predictions aren't exact, so remember we're sort of sampling from a probability distribution, we assume people sort of are too. So even if the one-to-one predictions aren't exact, we should be sort of still coming up with the same aggregate patterns of relationships. And so that's what we're really interested in. It's not necessarily that the model will come up with exactly the same word as a particular human profile, but we should be sort of seeing in the aggregate the same distribution of words relative to the kinds of profiles that it's getting. So I'll share with you 2 of the studies. There are 3 in the paper, but I'm going to share the first 2 today. The first one is pigeonholing partisans. So this is a published paper in which the authors ask Democrats and Republicans in the United States to list 4 words that describe their own party and 4 words that describe the other party. So this is a real task that they had human respondents do and publish that work thinking about the kinds of stereotypes that people have and express about the out party. And we ask it to do that too. So here's an example of all of the different kinds of prompts that you might see. We're describing their ideology, we're describing their partisanship, race or ethnicity, gender, economic status, age, all of these things. We're putting that all into the model. You'll notice this is like a first-person story, and we're just asking GPT-3 to then complete the story, right? So it says, when I'm asked to write down 4 words that typically describe people who support the Republican Party or the Democratic Party, I respond with 1, and then we expect it to continue to give us some words and then continue to count to 4. It does this task pretty well. So these are some actual examples of completions that we got from GPT-3 as in the course of the study. So you can see strong Republicans describing Democrats, so that's the top left corner, are going to say liberal, socialist, communist, atheist. So it's reflecting a bunch of stereotypes that people might have about the different parties. But how much does this match up to human responses? So we take the human data, we take the GPT-3 produced data, and we say, how often are they using the same kinds of words? So what we should see here is both the humans and GPT-3 are using pretty much the same set of words to describe Democrats. And they're not using any of those words to also describe Republicans. So we see that sort of on both sides. We see lots of sort of overlap in the kinds of words that are coming up. This is the top 10 words sort of for both groups. And we see, you know, lots of matching, lots of things coming up that are common, that are similar between GPT-3 and the humans. We see them not being used. We see them being used for Democrats, not for Republicans. We see the same thing on the other side. So the set of words, we now have a completely different set of top 10 words. They're used often to describe Republicans. They're used a lot less to describe Democrats. So we see like some evidence that we're using similar kinds of words, that we're thinking about things in the same way. We go a little bit further than this. So we're thinking about tone and content here. So this is based on the original study. They found, or they, you know, looked at sort of the prevalence of different kinds of content. So in particular, are people, when they're talking about these 4 words, are they mentioning traits that are characteristic of that group? Are they mentioning specific political issues that they associate with one party or the other? Are they mentioning sort of demographic groups? We saw sort of all of that in the example slide, but what we see here is this is very similar. So what's happening, we had some human respondents, some prolific respondents code each of these texts for the presence of traits, issues, and groups for both the human and the GPT-3 coded stuff. So we have the same process for both of them, and we see they're basically the same, right? We're seeing very similar kinds of patterns and outcomes in the prevalence of these different kinds of things. We also asked the human coders to tell us whether the text was positive or whether it was extreme. And we see sort of the same tone happening across both sets of content. Right, so what we're finding is like GPT-3 is mirroring what humans are doing pretty well. We look specifically at the positive texts and the judgments about positivity and extremity in the texts. That depends a lot on partisanship. So this is in line with the findings of the original paper. We find a lot of correspondence here between what GPT-3 is doing and what human samples are doing. And so it is sort of like picking up extremely liberal people say things that are less positive and say things that are more extreme about conservatives, and vice versa. And so we see both of these patterns playing out in data. So that's sort of the first study. I'll give you a brief rundown of the second study. And here we're taking the American National Election Study. So a big survey run every 2 to 4 years in the United States, typically around presidential election cycles. And we're using the 2012, 2016, and 2020 data. The version of GPT-3 that we're using finished training in 2019. So 2020 is a bit of an out of sample prediction. 2012 is a little bit temporally distant from the most recent of the training data, and 2016 is sort of the most recent election. And what we're doing here is we take all of this demographic information for each respondent in the ANES survey for that year. We feed it into GPT-3 with a prompt, and we say in the 2012 election or in the 2016 election, I voted for, and then have it produce the name of the candidate that I voted for. We pull those names out and sort of in a 2-party vote share, compare that to what is happening in GPT-3. And here we're sort of aggregating. So we're saying like, how much does the correlation between men in the sample, in the human sample and the ANES survey responses look like men in, or have sort of the same probability as men in the GPT-3 produced sample, in the silicon sample. So this is what we're doing. What we find is a very high level of agreement sort of across the board. There are a few small exceptions to this. So independents are very hard to predict. They're hard to predict for political scientists in the United States as well. But GPT-3 doesn't do well at predicting independent vote choice. But other things, it's very high. So the vast majority of these correlations are above 0.9. It seems to get sort of demographic relationships to vote choice pretty well, and is predicting this pretty well. So that's sort of the quick rundown of study 2. So some of our big conclusions from this paper. The first one is that we say that high algorithmic fidelity has to be established in whatever domain it is that you're interested in before proceeding with social science inference. So basically all we do in this paper is establish algorithmic fidelity for one particular kind of area. So for the GPT-3 model we're using in the domain of sort of national level American partisanship and politics, it seems to be generating responses that are matching human samples pretty well. The patterns underneath this match pretty well. Most of that's in study 3, which I didn't show you, but they're sort of like beyond the surface level. There's some associations on things that aren't political that it's picking up on as well. Another thing which I mentioned, this is a big part of how we're thinking about language models, is that a single large language model can produce a lot of different kinds of biases, a lot of different kinds of probability distributions for different conditioning texts. And so this allows us to generate silicon samples because it does seem to, the words that go into the context change then the probability of whatever follows. And so that allows for a lot of variation in the kinds of text that is produced by a language model. And we think there's huge potential here. For a variety of public opinion research tasks, we don't advocate, completely throwing out human research subjects in favor of language models. But there are a number of tasks where maybe having some pilot data that is reasonably informative is helpful. So some pilot data, some pre-testing, pre-registration, data imputation, sampling bias detection. There are lots of places where maybe there might be useful tasks that where language models can sort of augment what we're doing with survey data. We think this is especially true in a context where accessing high quality human survey research respondents is increasingly difficult and increasingly expensive. So there's even evidence now that a lot of crowd workers are using language models to then produce the text that they're submitting on online platforms for open text responses. And so even if you don't want to be using language models, you might be, even if we're trying to get human research responses. So we have to think a lot about sort of the trade-off between data quality and cost among human research respondents who are going to be harder to access, and what are the kinds of tasks that we can maybe shift to language models in order to free up some of those resources and some demand that we place on public survey research responses. Okay, we're going to move on. So that was sort of like one study that talks about using language models to produce synthetic data. The next one I'm going to talk about is sort of language models interacting in an experimental setting with human research respondents. This is not meant to be a comprehensive overview of potential uses of language models. There's lots and lots of research coming out on using language models for text annotation or coding, content coding tasks. All of that is super interesting as well. It's not something I'm going to cover here today, but there's a lot of other kinds of applications. So I'm focused mostly on my work. That's not meant to exclude anything in the big picture. There's a lot more going on here. But to talk about interactive stimuli, so here I'm going to move into a paper leveraging AI for democratic discourse, which was published in PNAS earlier this year, or last year as well. So a little bit of background to completely shift gears for a minute. Some of our research team, myself included, are political psychologists very interested in conversations and polarization and how people are talking to each other in their everyday lives or in their online lives. So some of the background for this, we're really very much coming at this from a deliberative democracy perspective. The conversation is the soul of democracy. It's important. It's part of how we break down barriers and come to compromise and what makes democratic systems work. And so with sort of like that framework, what we see is a lot of conversations that are happening online, and online conversations are not always stellar examples of deliberative exchanges. And so we can have lots of problems, and there's evidence from other social scientists that sort of this degradation of online discourse, that what people see happening online in political discussion, is impacting our offline behavior and is impacting sort of the landscape of our national politics. And so that can include people disengaging from politics altogether. So we sort of get this sorting by people who are really interested in politics and love the conflict and contention about it, and people who are just completely disengaged and checked out. It also seems to be linked to support for political violence. So some things that we don't really want to see happen if we don't have good discourse. So what we want to know is if language models can help us improve that discourse. There are lots and lots of folks working really hard on understanding the mechanisms by which we have better conversations. In the United States, there are lots of nonprofit organizations who do this work, and they do it very well. But we're interested in sort of figuring out, like, can we scale this up into an online context in a way that sort of uniquely takes advantage of large language models as a tool? So we start with a theory that increasing the perception of being understood by the other person in the conversation leads to better quality conversations and increased democratic reciprocity. So I'll talk a little bit more about both of those measures later, but those are the two outcomes we're looking at, sort of the quality of the conversation that they just had, and also this idea of democratic reciprocity, which is that we will sort of tolerate or sort of extend the same willingness to let other people have opinions that are different from ours that we hope people give to us. So there's sort of like a reciprocal nature there. And it really is about, like, even if I don't agree with this other person, I understand that they have the right to say something that I disagree with in the public sphere, or I can sort of understand that they might vote for different candidates, and their reasons for doing that can be good even if I don't agree with them. Right. So this is what we're looking for. We focus specifically on the perception of being understood because there's a bunch of research coming out of psychology, communication, that says that, like, feeling like the other person really heard you and understood you is actually a really important part of managing conflict in interpersonal conversations across areas. So this is not, a lot of this research comes out of, like, marriage counseling or counseling psychology, other communication spheres. So this isn't something that's sort of like unique to just the political sphere, sort of like a big picture tool that we have. If you can help somebody else feel heard and understood and respected, that can go a long way to changing the tone of conversations. So we're then asking whether artificial intelligence can help us give interventions that will help people sort of portray this perception of feeling understood to their partner, or portray to their partner that they are heard and understood. And in particular, what we think language models can do that is new is they can give this sort of feedback in real time, and in particular before people have actually said things. So other kinds of moderation are typically instruction that happens before people have a conversation that we then hope they're able to employ in an actual conversation setting. Or it's coming in after the fact and saying, no, that wasn't a good thing to say, right? Like, people have already said something. External moderators can only do so much after things have already been said. So what we're hoping is something like real time as people are having a conversation to help give them the tools to say things better. We want them to be evidence-based, and that we're relying on this evidence about the perception of feeling understood. We want it to be context aware. So it shouldn't be sort of like generic or formulaic. It should be something that matches the tone, the content, what's actually being said in a specific conversation. And we really wanted it to be not persuasive. So it was important to us that the language model was helping us with the tone, with the outcome of feeling understood, but wasn't necessarily changing people's attitudes or providing new content or arguments into the conversation. We want that, all of that sort of persuasive interaction, all of that conversation, all of the content of the discussion to still be coming from respondents themselves, from real people having conversations with each other. So this is what the study design looks like. Gun regulation is a big and important topic on which it's sometimes very difficult to get traction in conversations. People have a lot of big feelings about it. And so we have people come into an online conversation about gun regulation. We have 1,500 people in the conversations. Sorry, 1,500 conversations. We have a pre-chat survey. So they come in, they take a survey. We match them with a partner based on the information they're giving us about their position on gun control in that pre-chat survey. We move them into a chat room. Once they have their conversation, they have a post-chat survey, and then we did a follow-up survey a couple of months later. That's pretty much all I'll say about it, because by then the effects that we find have dissipated, which is not terribly surprising for a 5-minute intervention a couple of months ago to not continue to have a huge effect. The study design looks, in some of the chat rooms. So the experimental component of this is that in some of the chat rooms, one of the participants in the conversation, only one of them, just to help us with sort of understanding what's going on in the causal inference of this, one participant in the conversation is given an AI assistant tool. And that tool will randomly, through the course of the conversation, give them potential ways of restating, rephrasing what it was that they said. So you can imagine this sort of like hypothetical conversation. You've got two people, they're having a conversation back and forth. The person in blue has the access to the chat assistant. And so, they say something, the chat assistant intercepts. So basically they push send on their message. And instead of it actually sending, it pops up with a little window that says, here's what you said, here are some other things that you might have said. We don't label them like they are here. We have 3 different strategies, so they always get 3 different messages, one from each strategy. One of them is just restating what the other person said and then continuing on to say their own message. One of them is just politeness, so it's just a little bit of change in tone. One of them is validating, and so that doesn't mean agreeing, but it does mean, validating something that they can sort of respect about the other person, or even just acknowledging, I can see you care a lot about this issue or something like that. So it pops up with this little window. They can either choose to send their original message or one of these rephrased message. It was very important to us to keep the agency with the respondents in the conversation. So we don't force them into any of this. We don't even tell them, in the instructions, it says they'll get these suggestions. They might be better or worse than what they said. We try not to put a ton of pressure on people. They can still say exactly what they want to say. They also have an option to edit any of the messages before they send it. In practice, like 9 messages were edited. So that's not a very common outcome. Most of the time, about 2/3 of the time, respondents pick one of these rephrased messages and send that to their partners instead of what they had originally said. And then they carry on with the conversation. The person on the other side doesn't know that this is happening unless they read the consent document very closely, which we think is pretty unlikely. So the person on the other side sort of doesn't know that it's happening. They're just having a conversation, and this is the message that they get in the course of the conversation. Here's a screenshot of what the pop-up window looks like. Like I said, they can edit any message. It has their message, it has some alternatives, and they can just click the send button next to whichever one they feel like they want to send. So the first thing we need to do is find out if the artificial intelligence tool that we have created is doing what we want. So we have 2 goals. We really want it to change the tone of what's being said in the particular ways that we've described, but we don't want it to change the content. So that's the 2 things that we're looking for. So first, starting with the tone, these are a few of the sort of like relevant elements out of the politeness package from Mike Yeomans and Julia Minson and others. And so we're taking some of these tones that we think, or some of these features of text that we think reflect the kinds of things that we're trying to accomplish with our rephrasing instructions, and looking at it, and basically we do see a change in tone. We see a significant change in tone between the original messages to the rephrased messages in all the ways that we would expect. So we do the tone changes. Next, we want to know about content. So what we do is take all of the messages, we cluster them together and sort of like project them into this sort of networky space about this. So this is all the untreated messages. So this is everything that they sent that wasn't subject to rephrasing by the AI model. And we used GPT-4 actually in the end to create the labels for different groups of text. So we just sort of like read in clusters of text and have GPT-4 come up with labels. We see most of it is about gun control. There are some topics and themes that come out, but for the most part, like people are having conversations that are on topic that are about gun regulation and gun violence. And so this is sort of like the distribution space of all of the messages that aren't treated. Here's what it looks like for the treated messages. So in panel B, it's the topical distribution of the messages before they are rephrased. And then C is the messages after rephrasing. So what the people actually sent after getting a suggestion from GPT-3. And we don't see a lot of change, right? We're saying like basically the same structure, basically the same output here. So it's not like all of the, what we particularly didn't want to see was like a cluster that was all of the rephrased messages were all right together, because there was something semantically different about all of those. And we don't see that. We see like basically the AI seems to be keeping the content of the conversation while changing the tone, which is exactly what we were hoping for. The next level of results, we want to know what happens in the conversations. And so, like I mentioned before, we have 2 outcomes here. Both of them are indices of a set of survey responses, 3 to 5 survey responses in each of these indices. On the left is going to be conversation quality. So here it's a bunch of questions about the particular specific interaction they just had with the other person. One of the indicators there is they have to like grade the conversation from A to F. Other indicators about how they felt about the conversation they just had or the person they had the conversation with. On the right is democratic reciprocity. So here again is those measures of how willing they are to sort of tolerate disagreement. So sort of thinking beyond that specific conversation, we're asking about people on the other side of the issue of gun control regulation instead of just themselves personally. The big challenge that we end up having with analysis of the treatment effect here is that we have attrition over the course of the conversations, as you might expect from a sort of survey research project. The good news is people leave the conversation for a bunch of different reasons, but most of them still complete the follow-up survey. So a lot of them, it's like they're selecting to exit the conversation, but they still complete the follow-up survey and through the end of the study. So we still have outcome data for all of them, which is excellent. And then what we do, we also have a sort of placebo conversation, sorry, we have treatment controlled conversations. So we're taking the conversations of a particular length that had an AI intervention and comparing them to conversations of the same length that didn't have an AI intervention, right? So, and there's not any evidence of sort of differential attrition between those treatment groups. So we don't think the treatment is causing people to leave the experiment early. People leave the experiment early sort of at the same rate, we assume for similar reasons across the treatment and control group. So what we do is we start with the 0+ is like our ITT effect, right? That's all of the people who were assigned a partner, who entered the chat room, whether they sent any messages and had any rephrasing opportunities or not. So the 0 is the number of times there was a rephrasing intervention in a treatment conversation, or the number of times there would have been in a control conversation had they received the rephrasing. So the rephrasings are happening approximately every other turn in the conversation. And we're doing that in sort of like a calculated formalistic way. It's not based on the number of, or it's not based on any characteristic of the text. So we're not like picking only toxic comments to rephrase. We're rephrasing in every other conversation turn, right? So we can calculate sort of like, here's the number of rephrasings we had in a treatment conversation. Here's the equivalent conversation or the equivalent length conversation in a control conversation. We start with 0+, so that's sort of like ITT, that's everybody. And then the 1+ is just a subset of that. So it's people who had one or more conversation or one or more rephrasing interventions. 2+ is 2 or more rephrasing interventions, right? So each of the levels as you move down these graphs is a subset of the further one of just the people who continued on even longer in the conversation. Here's what the results look like. So the blue is, the gray squares are the control conversations that had no intervention. For conversation quality, we see that like as people have longer conversations, they feel like it was a better quality conversation. That's true for everybody. But we still see the treatment conversations. The gold triangles are people who themselves had access to the rephrasing tool. And the blue circles are people who were partners to somebody who had the rephrasing tool. And what we see sort of across the board is the partners of the people who had the rephrasing feel like it was a better conversation. And they also have more sort of democratic reciprocity, or they sort of express more tolerance, more willingness to disagree as a result of having the conversation. We also see that effect pick up for longer conversations among people who had the tool. So that's sort of like the stars by the gold triangles on 2 and more rephrasing interventions. So with a long enough conversation, both people who had the tool and people who didn't sort of improve on this democratic reciprocity score. We're not terribly surprised that the main effect is happening on the partner of the person who has the tool, because if you remember back to some of those strategies and our main theory is about the perception of feeling understood. So everything we're doing in these rephrasings is to sort of like restate and validate and be polite to the other person. So a lot of it really isn't about helping the person themselves express themselves better. It really is about sort of like an outward facing intervention to help the partner feel understood. And it seems like that's what's happening, right? Partners feel understood and like they had a better conversation. It doesn't, like, they may not be mirroring that back especially in a conversation this short. And so the people who have the intervention themselves aren't necessarily getting all of the benefit of it, but their partners definitely are, in a way that then has sort of like bigger picture effects on how they think about conflict and disagreement on this issue. So the summary, I showed you the manipulation text. GPT-3 seems to be doing the job that we asked it to do. The intervention improves conversational quality. It promotes democratic reciprocity. Those are good things. That's what we're hoping to find, is like a tool that can help us have better conversations in a way that sort of facilitates a deliberative democratic system. But the intervention doesn't cause attitude change. I didn't show you these results. They're in an appendix somewhere. But we don't see more persuasion happening in treatment conversations than we saw in control conversations, right? So there is a little bit of attitude change that results for some people as a result of having these conversations, but the intervention, the language model intervention, isn't causing any more of this persuasive effect. That's what we were hoping to find. We really didn't want the language model to be doing the work of coming up with arguments or to be mass manipulating attitudes. So we're happy to see that the intervention can do all of this without necessarily changing the content of the conversation. The effects are strongest for the partners of the people who have the tool. It does dissipate with time. I mentioned that. There are sort of another follow-up that we do. The effects are the largest when there's more initial disagreement. So this is actually a tool that works better in cases where people had starting positions that were farther apart. There's sort of a smaller effect when people are relatively close together in their initial attitudes. And one of the things that was important to us is that it respected human agency, that we allowed people to decide whether to accept any of these suggestions or not. They could still have complete control over the tone and content of their conversation. We just gave them some nudges about some other ways to say things that they could then take or not. So there's sort of like the big picture on that study. We think there's a ton of really exciting potential here for sort of both kinds of studies, for both kinds of research, and for, like I mentioned, a whole host of other things that are sort of beyond the scope of what I can cover today. But now we have some cautions and some caveats. The first one, so here's where I'm going to sort of shift away from those studies. I think I wanted to cover them because I think they give us a good foundation for thinking about what this looks like in research practice. But I sort of want to move to bigger picture questions of what's happening in language models and the developments that have happened since we conducted those studies. As I mentioned, we conducted both of those studies with GPT-3, both of them prior to the release of ChatGPT. So, for example, participants in our sort of chat assistant study didn't know, like, they probably figured there was some kind of AI behind it, but like ChatGPT wasn't a thing. Large language models were not a part of common conversation at the time we conducted that. So they really didn't have any concept for like what was going on behind these suggestions or where they were coming from, in the way that people would have a different reaction now if we were to do that. So that's one part of this, is that a bunch more models have joined the landscape. Particularly the release of ChatGPT changes things, but then we also have a bunch of competitors. At the time we ran those studies, GPT-3 was really essentially the only game in town. There were a couple of other model possibilities, but they were not as not as sort of the lower performance than GPT-3 at the time. So we've got a whole landscape of other models with different architecture, different training data, different strengths and weaknesses. So that's a part of this conversation, is when we started into this work, it was sort of like, what can large language models do? And we talked about GPT-3 because that was the only large language model that was really relevant at the time. That's not true anymore. Now we have this whole suite of models, which means we have to think about the landscape of the research in a different way. There are also some changes that happen in the way language models are trained. And particularly the difference between GPT-3 and ChatGPT exemplifies some of this. And I put it here as language models are not people, because we seem to forget that. Language models sound a lot like people. They produce text, they have a conversation with us, they interact with us in a way that it feels like we're talking to a person, when really language models are a lot more like the predicted text function of your phone than they are like a person. This is sort of a viral meme version, a little bit of a gruesome picture. So I apologize for that. But I think it's very good at sort of communicating what it is I'm talking about here. So GPT-3 is sort of like that unsupervised learning stage. It's sort of like the big monster. This is supposed to be a Shoggoth from H.G. Wells. And there's a lot going on there, right? All of the good, all of the bad, everything about human text is in those models. So if we talked for a little while about using language models to understand racism and racist attitudes better, because you could ask GPT-3 to be racist and it absolutely would do that. You can ask it to explain its racist attitudes. You could talk to it about what might change its mind. It would do all of those things. That has changed. So one of the things that has changed is sort of like the pink face there is the supervised fine-tuning layer, and particularly instruction tuning. So when we started with large language models, and in both of these studies that we're talking about, we couldn't give instructions to GPT-3. If you gave instructions to GPT-3, it would continue to write out more instructions, right? It just continues the text in whatever form and pattern you've started with. So we, start asking it survey questions, or we give it a first-person backstory and expect it to then just continue the text. There's an instruction tuning layer on it, which makes language models way more useful and way easier to interact with. We actually had a very hard time figuring out how to prompt engineer something so that GPT-3 would actually respond to survey questions, because that was not its natural state. Now it's much easier because it can follow instructions. You can say, answer this survey question. Here's what the answers mean. And it can sort of like, it's been fine-tuned in a way that it understands those instructions and gives it back. So that sort of like puts a little bit of a face on it. Means you can interact with it in this particular way. The reinforcement learning from human feedback, that last little bit, is sort of like what makes it this happy chatbot assistant. It's also, you sometimes hear talked about as like guardrails, the things that it says, oh, I can't offer an opinion about that because I'm an AI assistant and I don't have opinions, or, all of those caveats, all of those things that we put around it, is sort of like, it's just been trained to have that happy little yellow smiley face on the end. All of this monster is still underneath the model. We've just sort of constrained what it says in the output. Right? So they're not people. Underneath the hood, it is still just a predictive text engine. We've just now layered on top of that a set of expectations or training that says, here's the kind of text we want you to produce. And so that shifts. We talked about all of those probability distributions. That does shift the probability distribution. We shouldn't think it makes it way more useful in some contexts. In other contexts, it makes it much, much harder to interact with, or, not harder. It shifts the probability. It shifts what's happening underneath that model, or the kinds of responses that you're going to get, to be something that it is not going to be as reflective of sort of the whole population of the training text. The second caution that we have going forward is that prompting matters, but prompting is really brittle. So here's an example of a very good paragraph of this, which we won't spend a lot of time with, but there are just a ton of ways in which language models are really sensitive to the wording that goes into the prompts. And in ways that we think maybe it shouldn't. To us, it looks equivalent. To the model, it's not. And so changing small words, phrases, even adding additional irrelevant information is then going to change the kind of prediction that the model produces, and is going to change the output that we get. One example of this from our work in progress, which I'll just sort of briefly talk about, we're interested in seeing how much language models really can replicate conversation dynamics. And so we take this persuasion for good data. This is where two crowd workers are given, are having a conversation, and one of them has a task of trying to get the other one to donate money to a charity. And so we're looking at sort of like the frequency of donation for different kinds of conversations. The red bars are the human data. The green bars are when we prompted it as well as we could, but we didn't give detailed information about each of the respondents, like their demographics, their background information. So it was a good prompt, but not with specific information about the characteristics of people, and it does not do well. Okay. What we find is with a little bit more work, and when we give it something like the silicon sample-based prompting, so we're giving it a lot of detailed information about these crowd workers and who they are, then we have conversations that come to results that look a lot more like the human data. So this is just sort of like one of our examples of like what goes into the prompt really matters. And in particular, a little bit of evidence that maybe silicon sampling is an appropriate way of thinking about it, even in other tasks where maybe we're not as interested in like public opinion replication. The big picture takeaway I have from thinking about prompting is that just because a language model doesn't do something today doesn't mean it can't or it won't be able to soon. A different language model, a different prompt. It's amazing to me what surprising things happen in prompting that then lead us to have the capacity to do something. But the opposite of this is also true. Just because a language model can do something today doesn't mean it will be able to next week, right? Prompting changes in the model, changes to the model architecture, the training and fine tuning that's happening underneath it. Oftentimes these are opaque. We can't necessarily see them. They're happening behind the scenes with language model, curators, producers, companies. And so like models change and prompts, if you prompt architecture change, if you figure out something that works with one model, it may not work with the next iteration of the same model. It probably won't work with a completely different model. So even if you sort of like find the right prompt that does the thing that you want, there's no guarantee that that's sort of like a long-term thing that it's always going to be able to do using exactly the same sort of replication code. Some practical prompting tips. I won't spend a lot of time on these. The first one is to understand the model. So understanding what you need to do with prompting helps a lot to know what's behind the scenes on this model. How has it been trained? What's its core task, right? Which is typically prediction, next word prediction. But then also, how has it been fine-tuned? So what are the alignment axes of that particular model? What are the ways in which it's been instruction tuned and fine-tuned? And how is that going to affect how it responds to the particular request that you have? And how should you think about that in trying to get sort of the language model into the right space for the task that you're trying to do? I'll say along with that, prompting is not yet sort of a one and done process. So I don't think we're at a point where we can just sort of come in with no experience, pre-register a prompt and say it worked or it didn't work. Prompting is very much an iterative engineering problem. And I don't think we're yet at the point where we can say like, this is a good prompt and it will totally work. And this is a bad one that won't work without spending some time, producing some data and seeing what happens. Sometimes to our scientific brains that feels weird because we sort of want to pre-register or have our hypothesis or test it. But this is really much more of an engineering problem. Prompting may not solve every problem. There are some tasks for which language models are not the right tools. They are very bad at math. There are other coding and text annotation tasks that a smaller, specifically trained model on your data is going to perform better than a large language model. So prompting can get you a long way and sometimes in very surprising far, but it's not going to solve every problem. Okay, my last little bit. I'm going to just sort of briefly run through where I see 3 problems right now and give sort of 3 propositions for what we do with that. The first problem is sort of this proliferation of conflicting findings. So one example is after we publish our out of one many study, there are a whole bunch of other studies. And if you've done this work and I don't have you here, I'm sorry, please send it to me. Language models are pretty good at mimicking human responses. So we have some studies that show this in a variety of different domains, except when they're not. And so then there's also a bunch of studies that say, they have biases, they're not very good at replicating responses in these different ways. And so how do we think about reconciling these conflicting findings? Our recommendation here is that we really need to focus our research on specific conditions and contexts and not general capacity. Any one study is not going to prove what language models can't do, particularly if the answer is no, right? Finding that this language model with this prompt doesn't accomplish the task that I want doesn't actually mean anything about another language with another prompt or another training data or a related but slightly different task. And all of those details really matter for what language models can and can't do. And so we think we'll more productively and efficiently build knowledge in this area if we're really specific about the conditions and the context that we're looking at. So it works under these conditions, it doesn't under these. By conditions and context, we mean what's the model, what's the prompt, what's the time at which it's being run, what's the specific nature of the task. The second problem is evaluating the performance of a large language model. How do we know? This is the big question. If we want to use language models in social science research, how do we know the language model is doing the task that we need it to do? We probably, because of all of the reasons I've just described about changes in model, about prompt instability, about how hard it is to move things across contexts, we can't really rely on other people's validation exercises. So in the social sciences, especially in methodology work, we're used to somebody publishes the methods paper that says, here's the proof of why it works. Here's some examples of why this is the better tool in all of these situations, and then we just cite that paper and we carry on with our work. And that's not going to be the model for language models right now. We can't rely on other people's validation exercises because models change. Models are different, prompts change. There's no expectation that just because it worked even in our papers, right? Don't cite our paper and say like that means you can do prediction in other political domains without validation. So that's our second proposition, is that we need to collectively establish some LLM benchmarks. What does this look like? What looks like doing the task well? This is a collective endeavor. I don't think this is something that any one of us can sit down and say, these are what the benchmarks are and should be. But it's something that collectively as a community, we need to be having a better conversation about what the benchmarks look like and how to know when we have met them. In the meantime, until we have those kinds of benchmarks, validation should be an integral part of every LLM study in the social sciences, right? So every language model study should be saying, we use this language model to do this particular task in our study. Here's the evidence that it works, that the language model in the way that we're using it at the time that we're doing it is doing the task that we wanted it to do. And then we can sort of carry on with the rest of the research. But I think that has to be, for the time being, every study has to reestablish that the language model is doing the task that we want it to be doing in that particular context. That's a lot of work. So hopefully we can come to some better understanding of benchmarks and context, and so that we can sort of build a body of knowledge that helps us understand this better. But in the meantime, as we're working with these models that are new and rapidly changing, sort of, I think, has to be every time. Our last problem is replicability and transparency. So this is a big conversation that's happening around language models, and it's for a reason, right? Replicability and reproducibility is hard with language models. There's randomization built into the model in a way that we can't like set some random seed. Temperature doesn't do this for us to then get exactly the same content out of the model every time. And the models change without warning. There's a lack of transparency about what's in the training data. Prompt engineering matters a lot. And so all of these things mean it will be very hard to replicate and in some cases even reproduce the same exact thing. The debate about open versus closed source models, I think, is a really tricky one. In some ways, open source models have more replicability, they have more transparency, we know a little bit more about what's in them. It's easier to then reproduce exactly the same thing because we can have a little bit more control over what's happening in the model and when it's updated and changed and what those weights look like. But there are still big questions about sourcing of training data, ethics questions there. There are questions about the state-of-the-art capability. So open source models are always going to lag a little bit behind the leading industry state-of-the-art. The guardrails for the model are sort of a mixed bag, right? In some cases, right, they're going to be less likely in open source models. In some cases, that may be a good thing. What we really care about is sort of the full underlying unbiased distribution. But in other cases, it's going to be really necessary. So for example, if I'm taking a language model and I'm having it interact directly with people, I want some of those guardrails there. I don't want language models suggesting violence or giving, giving racist or sexist remarks or being uncivil to respondents. And so there are, I think it's sort of situation dependent, whether that's the kind of thing you want in your model or not. Researcher technical capacity is also a huge question here. Closed source models are very easy to use, right? It's just a couple of lines of code to call an API. That's a very low technical hurdle, which allows a lot more people to be engaged in this research. Open source models are going to be a much higher technical capacity hurdle. What we want to suggest a little bit is that survey research standards might be a model for thinking about replication and transparency. So in a lot of applications, language models are a data generating process, not a data analyzing tool. And so we wanted to come to them with our machine learning backgrounds and say, set a random seed, give me the same output and predictions every time. But in a lot of cases, and particularly in the cases that I've described to you today, the language model is functioning as a data generating process. So maybe we need to think less about specific reproducibility and more about replicability. And in there, we're thinking about survey research. So there's no expectation for a survey researcher that if you, produce survey data, if you go sample somebody who produced survey data, that you should be able to go back to, even using the same, recruitment method and the same sample parameters, or even researching exactly the same people, that you should be able to go back to them and get the exact same survey data back. But that doesn't mean we use survey research as sort of like not replicable and not transparent. And so we just need to think about what are the things that we care about the transparency. We should be transparent about our sample, which in this case is probably the model, the training process, the survey dates. We should be really clear in communication and justification of our design decisions. So that includes the prompts. We should be putting prompts in the main text of results, not burying things in supplemental appendix files, just as we would expect the survey questions being asked, or our survey treatment in an experiment to be put directly in the main text of the article. We should be providing all of the generated data and then the reproduction files for all of the analysis. So the data that's produced by the model needs to become a part of the archive process, not just the process by which that data was called. And we should be documenting and transparent about any iterative steps we're taking in that process. So that's the third and final proposition here, is that we need to develop standards of replicability and transparency that are appropriate to the nature of large language models. And in some cases and particularly maybe for coding applications, for text annotation applications, that might look a lot like reproducibility, but in other contexts, we might want to think more broadly about the kind of work that large language models are doing in our research and what the appropriate standards look like, so that journals, reviewers, all of us know what to expect and are communicating clearly the important information. All right, this is my very cheesy wrap-up slide here. I think there's a ton of potential. I'm very excited about large language models, about what they can do. I think they have a lot of potential to be a very useful tool in a range of social science research tasks. But there are some reasons to proceed with caution, and we should, I think, be having open and intentional conversations as a field together about what the right standards look like and how to move forward. All right, I will wrap up there. I will note the rest of my team here, which this work wouldn't happen without all of us. So thank you for your time. I'm happy to answer some questions now.